Hi everyone, welcome back to the tutorial of KServe. And in this video, we are going to deploy our first machine learning model using KServe on Kubernetes. And I'm going to guide you through creating an inference service with a pre-trained Scikit-learn Iris model. And we are going to understand how the YAML configuration works and how can we send a test request to our inference service. So I'm here on my Google Cloud Console dashboard, and we can see the Kubernetes cluster is up and running. And in the last video, we installed KServe and some of the various components that are necessary to use KServe onto our Kubernetes cluster. So let's start deploying our first inference model onto the Kubernetes cluster. So I have already opened the project directory, and I'm going to create one YAML file where I'm gonna define my inference service and some of the resources and a and the namespace where I'm going to deploy this. So I just named my file iris inference service.yml, and I have already written the code for the YAML file. So I'm just gonna paste it here. So yeah, here is our YAML file. So let me walk you through the YAML configuration and let me specify what are the components we have it here. So first of all, we have API version, and this specifies that we are going to use KServe as an API version, and then we have a kind. So the kind of this file is the inference service, which is defining which basically it's telling our Kubernetes cluster that it's an inference service that had to be booted up. Then we have some metadata, for example, a name. So it's a simple name Scikit-learn Iris, and then we have a namespace where I'm going to deploy this YAML configuration. And then we have some few spec file, which is having like a predictor, sklearn, in which we have mentioned the storage URI. So it's nothing but the location where we have the model available. So we have provided the Google Cloud Storage location, and then I specify certain resources and limits. So resources are like that I am requesting Kubernetes cluster that I need 500 unit of CPU and 512 MBs of memory. And these are the limits, the maximum capacity this service can utilize on a cluster. And if a service tries to, basically, if a deployments try to exceed this limit, then the Kubernetes cluster will automatically and gracefully terminate that deployment so that the other services keep running on the cluster. So now let's start deploying our Iris inference. So as you know, we are already connected to our Kubernetes cluster, and to verify that, we can simply do kube control get ns, and we can see all the namespaces available here on my Kubernetes cluster. Now I'm going to navigate to this project directory where I have this file. So this is my project directory. And first of all, we have to create a namespace. So as I mentioned in my YAML file, I'm deploying it a KServe-test namespace. So I'm going to create one namespace here. So it's very simple. We just have to do kube control, create namespace, and then the name of the namespace. So now you can see the namespace is created. Now I'm going to deploy this file. So to do that, again, we are going to use kube control, and I'm going to use apply command with the flag, and we are going to provide the path to that file. And the resource of inference service has been created on my Kubernetes cluster. But So to check whether the resource is there and what is the status, there is again a get command in kube control, which we can simply use to locate this resource. And I have provided here the model name and the namespace. So if I press enter, I can see the model is not yet ready and it's still false here. So it's going to take a while to get deployed. And once it is deployed successfully, we're going to get the endpoint where we can access this mod. So let's wait for a bit. So now you can see our model is deployed and we are having an endpoint here and the status ready has been changed to true. And we have an endpoint which we can use to basically hit the model API and get the relevant output. So let's try out this endpoint and try to get some prediction out of this model. So before that, we have to gather certain components. So first, we have to get the external IP of the gateway. So to do that, we can simply use get command and we can get that IP from the ingress gateway of the Istio. And we can see we have the external IP here is like this particular IP address. And we are going to store that temporarily into our in one of the variables. So I'm creating a variable ingress host where I'm going to store this endpoint. And similarly, I'm creating another variable where I'm going to store the port number. And I'm going to provide all this command in the README file as well. And after that, we have to create a file where we are going to basically have all the which we can send to the model API and get the response out of it. So I'm going to create one file, iris input.json. So this is going to be my payload that I'm going to send to my REST API, and I should be getting some prediction out of my REST API when I pass this payload to this specific endpoint of Iris model. So another thing we are going to store is a service name into this service variable. So I've created this variable into my terminal and I'm storing it. Now to simply hit the model endpoint, we have a very basic curl command where we are passing the service name as a host and we are passing the ingress host that we stored earlier and the port number. And this is the endpoint of the API. And we are doing predict and we are passing our JSON file that we just created. So if I hit enter, you can see we are having a 200 response from our model and we are getting some predictions here, which means we have successfully deployed our first machine learning model on Kubernetes using KServe.